Alright, 28. Standard XY coordinate plane. The graph of which of the following equations is a circle with the center of 2, -4 that passes through the point 2, 1? Well, first we have to remember that the center radius form of a circle is defined by x minus h squared plus y minus k squared equals radius squared. Great. So then in that case, what we can say is that since we know, well, we should remember, I guess, is that h comma k represents the center of the circle and r represents the radius of the circle. Well, we are given, right, we are given the center of the circle. So if we replace those values here, this h is going to be a positive 2, and then this k is going to be a -4. So that one is a little bit trickier because we just got to reverse the sign, but ultimately we should look like x minus 2 plus, I'll do this again so you can see it, y minus -4 squared equals r squared. So I forgot the squared there. Alright, now that that's fixed, it's going to be x minus 2 squared plus y plus 4 squared equals r squared. That should get us somewhere because that should allow us to eliminate. We know it's x minus 2 to start, so it ain't g, and it ain't j, and it ain't k. And then from there, we know it's got to be y plus 4, so it can't be h. So it's got to be f. And by process of elimination, man oh man, that's quite helpful. We would have to have used Pythagorean theorem to solve for the radius if we had wanted to. It would not have been hard, and why not do it just for the sake of doing it? Because it could come in handy. So let's go ahead and say to ourselves that it has a center at 2, -4. I'm just going to freehand this as best I can. So here's the center at 2, 4, and it passes through the point 2, 1. So there. So this is 2, -4, and this is the point 2, 1. So again, just visualization purposes, again, this ain't gonna be perfect, guys, but you will deal with me here. It will look something along these lines. So perfect. And well, that's quite helpful for us because what we can see here, we don't even have to do Pythagorean theorem, because if we look at it visually, we can see that this is the x coordinates are lined up, so the radius will just be a straight line. We don't have to do Pythagorean theorem, we can actually just count. So it's the distance between our x's, which gives us a radius of 5. Perfect. So don't even have to do that. So since that gives us a radius of 5, then we put that in, that's 5 squared, and so then that gives us 25 ultimately. So confirms 28. Back to this one last thing, because I mentioned Pythagorean theorem, might as well say it. If we had another coordinate over here that wasn't lined up, we would have to create ourselves a right triangle, and using the coordinate points, we would have to determine the distances of the legs to figure out that radius there using Pythagorean theorem. Okay,